We are now looking at problem 8.5 on page 275, 6th edition of McMurray and Fay. We are looking at the reaction where 2 moles of hydrogen is reacting with 1 mole of oxygen to yield 2 moles of water. In our reaction mixture, we have half a mole of hydrogen and a quarter mole of oxygen at a pressure of 1 atmosphere. The reaction enthalpy is given as minus 484 kilojoules. There's a change in volume. The system's volume is contracting, therefore it's negative. So the change in volume is minus 5.6 liter. Now it's asked that we need to calculate the PV work as well as the change in energy in kilojoules. When quantities of reactants are given, one always needs to think or ask oneself, is there a reactant which is limiting? So therefore we look at the stoichiometry of the reaction where we see that 2 moles of hydrogen is reacting with 1 mole of oxygen. So the hydrogen is reacting with the oxygen in a 2-to-1 ratio. When we look at our reactants, we also notice that it's also in a 2-to-1 ratio, which means neither of our reactants are limiting. If one was limiting, we would have used the one that's limiting in our calculations. So now we can calculate the PV work. So work is equal to the minus the pressure times the change in volume. So our pressure is 1 atmosphere and our change in volume is minus 5.6 because the system is contracting. So a minus times a minus gives us a positive value of 5.6 atmosphere liter. When you do calculations, always use units. So our pressure is a unit of atmosphere. Our change in volume has a unit of liters. So atmosphere times liter gives us a unit of atmosphere liter. But now you see the change in energy we need to calculate in kilojoules. So we need to convert this unit atmosphere liter to something which contains a joule. So therefore we multiply it by this conversion factor, which is 101 joules per liter per atmosphere. Now if we take this per liter multiplied by the liter, the 2 units cancel. If we take this per atmosphere multiplied by the atmosphere unit cancels and we're only left behind with joule. So the answer is 565.6 joules, which is the same as 0.56 kilojoules. So the change in energy is given by delta H minus P delta V. Now we need to calculate delta H. The delta H given here, which is minus 484 kilojoules, is for 2 moles of hydrogen. But in our mixture, we have 0.5 moles of hydrogen. So the quantities are different. So we need to recalculate this delta H for 0.5 moles of hydrogen. So we have minus 484 kilojoules for 2 moles of hydrogen multiplied by the amount of hydrogen that we have, which is 0.5 moles. That gives us a value of minus 121 kilojoules. So this value of minus 121 kilojoules is for a half a mole, 0.5 moles of hydrogen. Okay, so the change in energy is given by delta H minus P delta V. Now that term we've already calculated, that's the PV work. So work is equal to minus PV delta V. So that whole term, including the minus, is equal to 0.57 kilojoules. So that whole term is equal to 0.57 kilojoules. So now we have delta H, which we've calculated for half a mole of hydrogen, which is minus 121 kilojoules, plus a PV work, which is 0.57 kilojoules, and the answer therefore is minus 120.3 kilojoules.